Okay, now we're going to do page 3 and 4 of non-right triangle. 9b, the cosine rule. Okay, let's write down the cosine rule, which we found in the investigation. Basically, it's c squared equals a squared plus b squared minus 2 ab cosine of c. So the cosine rule can be used basically when you know all these, which would be two sides and one included angle, or if you happen to know this, this, and this, then you can figure out the angle. Okay, so if you know all three sides, or if you know two sides and one included angle, then you can use the cosine rule. Okay, what happens in the ambiguous case for the cosine rule? Okay, you might be given this length and this length and the angle. Okay, so then you know A, but you don't know B. In which case, this is going to be unknown and this is going to be unknown. So the B's are going to be unknown. What you're going to end up with is kind of a quadratic. You're going to get x squared plus something, x plus something. It's a quadratic, right? And remember, quadratics, when they're set to equal 0, they sometimes have more than one solution. So your other unknown length, b, it might come out to be two possibilities. Okay, so that's what happens with the ambiguous case. Like, if you know A, C, and C, then B might have two possibilities. Okay, so that is the ambiguous case for the cosine rule. Okay, find the length of the remaining side in the given triangle. So we have included angles here, so these are relatively simple cases of applying the cosine rule. So let's see, we are looking for the A side. So that we would use the formula a squared equals b squared plus c squared minus 2bc cosine A. And you can see that this is like pretty easy to memorize. So a squared is equal to b squared, which would be 21 squared plus 15 squared minus 2 times 21 times 15 times the cosine of a, which is the cosine of 105 degrees. So we're just going to figure out what the cosine of 105 degrees is, which we can do with our calculator. Our calculator is still in degrees mode, so we'll do cosine of 105. And that'll give us negative 0.259. Negative 0.259. And then we can just multiply that out, and we'll get an a squared value, and then we take the square root, and then we get the a. Okay? All right, now this one is very similar. So we just put a squared equals 6.2 squared plus 14.8 squared minus 2 times 6.2 times 14.8 times the cosine of 72. Cosine 72. Okay? And then you just multiply that out and take the square root, and that will be your value for A, which is this unknown side. Okay? Yeah, that's exactly right. Okay. Number 3. Find the measure of the obtuse angle PQR. So PQR would be this angle, PQR. Find the measure of this angle. Okay. So this is like, let's say this angle is A. We can still use the cosine rule to do this because we know everything except for A. So like we could do, let's see, A squared equals b squared plus c squared minus 2ab cosine of capital A. So the a squared is going to be that, right? And these are going to be b and c. Doesn't matter which is which. So it'll be 10 squared equals 5 squared plus 7 squared minus 2ab would be 2 times 10 times 5. 2 times 10 times 5. 2 times 10 times 5. Cosine of A. Okay. And then you can see how just if you multiply this out, 100 equals 25 plus 49 minus 2 times 10 times 5, which is 100, cosine A. Now you just do a little bit of algebra, and then you'll end up in the end with cosine A is equal to, something, and then you can just take the inverse cosine of that to get the angle A. Okay? And that something would be, let's see, 25 plus 49 is 74, and minus 100 would be minus 26. So cosine of A is equal to negative 0.26. That looks familiar. Look at that. That's negative 0.26. They're recycling the numbers again. So it's actually 105. A is 105. Okay, A is 105 degrees. Okay, number 5. Find cosine theta, but not theta. Okay, so if we want the cosine of theta, that means the adjacent over the hypotenuse. So that would be the adjacent over the hypotenuse. So cosine of theta is equal to 2 over 5. That is the cosine. They said not to find theta. Okay, find the value of x. X is here. Okay, so let's see. I'm taking it that this is not a right angle, which would make things a little bit more difficult. So, so this whole thing is 3. Since we know the cosine of theta is 2/5, we could now use the cosine rule to figure out what x is, because we have an included angle here, right? Okay, so we have a squared equals b squared plus c squared minus 2bc times cosine of a. And the cosine of theta we know is 2/5, so we can fill that in. A, we don't know what it is yet. B squared is going to be 5 squared. C squared is going to be 3 squared. Minus 2bc would be 2 times 5 times 3. And then times 2/5. Okay, so a squared would be 25 plus 9 minus 2 times 5 times 3 divided by 2/5 would be 2 times 2 times 3, which is 12. Okay, so it would be 13 plus 9, which is 22, something like that. So a is the square root of 22. Or that's actually x equal to x. They said to find x. Find the exact value of x in each of the following diagrams. So, let's see. We do not have an included angle, right? Because this is the unknown. So, let's see. If we have this form, a squared equals b squared plus c squared minus 2bc cosine A, cosine A is going to be cosine of 60, okay, and B and C are going to be 2 times x times 6, and then C squared is going to be 6 squared, and B squared is going to be x squared, and A is going to be 7 squared. So that's equal to 49 equals x squared plus 36 minus 12x. And cosine of 60, remember when you draw the unit circle triangle, the cosine of 60 is 1/2, so that's actually 1/2 of 12 is 6. Okay, so here we have, and let's set this equal to 0, so we're going to have minus 49 to both sides. That would be negative 13. Oops. Negative 13. So now to find the solutions here, we need to use the quadratic formula. Remember that if you're allowed to use a calculator, the calculator has poly-SMLT, which has a root finder on it, the poly root finder. And to use the poly root finder, first you just say that it's a second order equation, then you say next, and then you just give it the coefficients. So you give it 1, negative 6, and negative 13, and then it will find the roots in a second. Negative 6 and negative 13. Oops, 13. And the roots are 7.69. And the other root is negative 1.69. Okay. C. So this is a similar problem, except now they at least give you the proportion between these two. We're just going to set it up because in the end this is just going to give a quadratic also. Okay, so let's see, we're going to use the same equation here, except in cosine A is going to be 1/2 again because it's 60, right? And we're just going to fill in the numbers. So this would be A, and this would be, like, let's say it'd be B, and this would be C. So let's see, A squared, 5 squared is equal to 5 squared is equal to B squared, which is x squared, plus C squared, which is 2x squared, minus 2 times B times C times the cosine of A, which is 1/2 because it's cosine of 60 degrees. So these cancel, and then we have minus 2x squared here, and then we have 4x squared here, and then we have x squared here, and that is all equal to 25. So 25 equals, let's see, 5x squared minus 2x squared is 3x squared, and 25. And so basically this is x squared equals 25 divided by 3. So x is equal to 5 over the square root of 3. Okay. Actually, that wasn't too bad, was it? It wasn't. Oh, by the way, and like, you know, we didn't say this, but when you get two roots like that, obviously one of these roots does not work as a length, the negative one. So actually there's only one possible value, 7.69. Okay. Last one. Show that there are two plausible values for x in this triangle. Okay. So one of the values, let's see, this is going to be, let's see, a squared equals b squared plus c squared minus 2bc times cosine of a. And once you do a few of these problems, you've already got it memorized, even though it's in the formula sheet, right? Cosine of a is going to be cosine of 40 degrees. This is going to be a, this is going to be b, this is going to be c. So a squared is 5 squared, b squared is x squared, c squared is 6 squared, minus 2 times x times 6 cosine of 40. Okay, so this is going to be 25 equals x squared plus 36 minus 12x cosine of 40. And so this is heading toward a quadratic equation too. We're going to subtract 25 from both sides. We'll get 0 equals x squared, and then this will be plus 11, and then minus, and I'm going to put this plus 11 over here, And then I'm going to, let's see, cosine of 40, what's that? Cosine of 40. Cosine of 40. I'm still in degrees mode, so I'm fine. 0.766. So 0.766 times 12, 9.19. 9.19x. Okay, x squared minus 9.19x plus 11. Okay, and so we can put that into poly-SMLT to find the roots. So first we say polyroot finder, and then we say it's a second order equation, and then we say the first coefficient is 1, the second coefficient is negative 9.19, and the third one is 11. Solve. And so there's two roots, 7.78 maybe, right? And 1.41. And both of these are positive numbers, so both of these are possibly values for x that work, okay? And you can see that one of them is going to make the triangle actually look like this, because this brown line is going to be longer than 6. It's going to be 7.78. So if it's 7.78, the triangle is going to look like this brown outline, and if it's 1.41, it's going to look like the orange outline. Okay, so this is, remember when we talked about the ambiguous situation, or I forgot what it's called. Let's go back here and look. It is called the ambiguous case. So in the ambiguous case, you have a solution which could be one number or the other. Okay, thank you.